As we called up before, when using Git to work on a new feature or a big refactor of some kind, it's recommended best practice to create separate branches. There are many advantages to doing this. For example, it might take you a while to finish a new feature, and in the meantime, there could be a critical bug that needs fixing in the main branch of the code. By having separate branches, you can fix the bug in the main branch, release a new version, and then go back to working on your feature without having to integrate your code before it's ready. Another advantage of working in separate branches is that you could even release 2 or more versions out of the same tree, one being the stable version and the other being the beta version. That way, any disruptive changes can be tested on a few users or computers before they're fully released. So let's start a new branch to work on a small refactor of our code. You could create the branch first, and then check it out. Or we could just create it and check it out with git checkout-b and the new branch name. We're ready to start working on our refactor. Let's open up the file and have a look at it. We've noticed there's a pattern of repeating code in our check free space.py script. For each check that we call, we check if it returns true or false. When it returns true, we print an error and exit. If we add a new check, we'll have to repeat this pattern again. On top of the repeated pattern, if a computer has more than one problem, only the error for the first one will be printed. So let's refactor our code to avoid the duplication and print all relevant errors. We'll do it step by step, making each commit self-contained. The first thing we'll do is create a function that checks if the disk is full without any parameters, so it matches the pattern. This new wrapper function will pass the right parameters for us. Then we'll change the code to call this function instead. We'll also change the error message to something more accurate. We've changed the function. Let's save and test our code. Awesome. It's working. Let's commit the change. Now, we're ready for the next step in our refactor. To avoid code repetition, we'll create a list containing the names of the functions that we want to call, and then message to print if the function succeeds. After that, we'll add a for loop that iterates over the list of checks and messages. Then we'll call check, and if the return value is true, print the message and exit with an error code of 1. After doing that, we can delete the old code that we've already replaced. This change made, let's save once again and test that our script still runs. Yes, it's still working. Let's commit the new change. By now, we've refactored our code to avoid code duplication. The current code does the same as the old code. Once we're ready to add new checks, we can do that by adding the function name and error message to the list of checks. The last change that we want to do is to let our script show more than one message if more than one check is failing. To do that, we add a Boolean variable called everythingOK before the iteration. Change this variable to false if one of the checks find a problem, and then exit with an error code only after having done all the checks. All right, one last time. Let's save and test to see if this works. And now let's do a file commit for this change. With that, we have 3 commits in our refactor branch. Before we merge any of this into the master branch, we want to push this into the remote repo so that our collaborators can view the code, test it, and let us know if it's ready for merging. The first time we push a branch to a remote repo, we need to add a few more parameters to the git push command. We'll need to add the -u flag to create the branch upstream, which is another way of referring to remote repositories. We'll also have to say that we want to push this to the origin repo and that we're pushing the refactor branch. That's a lot of information that Git's giving us. It's telling us if we want, we can create a pull request. Now, we see that a new refactor branch has been created in the remote repo, which is what we wanted. So now that our branch is pushed to the remote repo, it can be reviewed by our collaborators. Assuming they say it's okay, how should this branch get merged back into the main branch? We mentioned that once our branch has been properly reviewed and tested, it can get merged back into the master branch. This can be done by us or by someone else. One option is to use the git merge command that we discussed earlier. Another option is to use the git rebase command. Rebasing means changing the base commit that's used for our branch. So how do we do it? We run the command git rebase, followed by the branch that we want to set as the new base. When we do this, Git will try to replay our commits after the latest commit in that branch. This will work automatically if the changes are made in different parts of the files, but will require manual intervention if the changes were made in other files. Let's check out this process by rebasing our refactor branch onto the master branch. First, we'll check out the main branch and pull the latest changes in the remote repo. Git tells us that it's updated the main branch with some changes that our colleague had made. At this point, the changes that we have in the refactor branch can no longer be merged through fast forwarding into the main branch. That's because there's now an extra commit in the main that's not present in the refactor. Let's see how this looks by asking the log command to show us the current graph of all branches. It might take a bit to follow everything that's going on with this graph, but it can be really useful to understand complex history trees. As you can see, the refactor branch has 3 commits before the common ancestor, with the current commit that's at the head of the main branch. If we merge our branch now, it would cause a 3-way merge, but we want to keep our history linear. We'll do this with a rebase of the refactor against main. As usual, Git gives us a bunch of helpful information. It says that it rewound head and replayed our work on top of it. And luckily, everything succeeded. Let's look at the output of git log --graph -one line for our branch right now. Now we can see the main branch and linear history with our list of commits. We're ready to merge our commits back onto the main trunk of our repo and have this fast forwarded. To do that, we'll check out the main branch and merge the refactor branch. We were able to merge our branch through a fast-forward merge and keep our history linear. We're now done with our refactor and can get rid of that branch, both remotely and locally. To remove the remote branch, we'll call git push-delete origin refactor. To remove the local branch, we'll call git branch-d refactor. We're done with our refactor. We can now push changes back into the remote repo. Alright, we've just gone through an example using the git rebase command. We had a feature branch created against an older commit from main. So we rebased our feature branch against the latest commit from main and then merged the feature branch back into main. We've looked at a lot of things we can do with Git and remote repositories. it's worth spending some time talking about best practices for collaborating with others. It's a good idea to always synchronize your branches before starting any work on your own. That way, whenever you start changing code, you know that you're starting from the most recent version and you minimize the chances of conflicts or the need for rebasing. Another common practice is to try and avoid having very large changes that modify a lot of different things. On top of that, if you remember to push your changes often and pull before doing any work, you reduce the chances of getting conflict. We called out already that when working on a big change, it makes sense to have a separate feature branch. This lets you work on new changes while still enabling you to fix bugs in the other branch. I'll make the final merge of the feature branch easier. It makes sense to regularly merge changes made on the master branch back onto the feature branch. This way, we won't end up with a huge number of merge conflicts when the final merge time comes around. If you need to maintain more than one version of a project at the same time, it's common practice to have the latest version of the project in the master branch and a stable version of the project on a separate branch. We looked at how we can use rebase to make sure our history is linear. Rebasing can help a lot with identifying bugs, but use it with caution. Whenever we do a rebase, we're rewriting the history of our branch. The old commits get replaced with new commits, so they'll be based on different snapshots than the ones we had before, and they'll have completely different hash sums. This works fine for local changes, but can cause a lot of trouble for changes that have been published and downloaded by other collaborators. So as a general rule, you shouldn't rebase changes that have been pushed to remote repos. The Git server will automatically reject pushes that attempt to rewrite the history of the branch. It's possible to force Git to accept the change, but it's not a great idea unless you really know what the implications will be. In our feature branch example, we rebased the branch, merged it to the main, and then deleted the old one. That way, we didn't push the rebase changes to the refactor branch, only to the main branch that hadn't seen those changes before. Early in our Git journey, we mentioned that having good commit messages is important. It's already important when you're working alone since good commit messages help the future you understand what's going on, but it's even more important when you're collaborating with others since it gives your collaborators more context on why you made the change and can help them understand how to solve conflicts when necessary. So commit to being a good collaborator and remember to add those commit messages. You have unlocked Git and GitHub with Databits Central. If this helped, smash that like button, subscribe, and ring the bell. New videos are consistently being released to keep your skills sharp. A Git cheat sheet in the description. What's your Git struggle? Let me know in the comments. Thanks for watching, keep coding, and see you soon.